So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is max dot product of two subsequences. So given two arrays nums1 and nums2, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. A subsequence of array is a new array, like they've just given the definition of the subsequence, like a subsequence is nothing but by removing some elements without disturbing the relative order of the entire array. So what you need to do, you need to pick one of the subsequence from nums1 and one of the sequence from nums2 which is non-empty and are of same length, and you need to find the dot product of it. So this is a actually hard problem, but if you have solved longest common subsequence, then this is a pretty much easy problem because it uses the same concept of longest common subsequence only. So let us see the first example and try to understand what the question is saying. So you can see the nums1 array is 2, 1, -2 and 5, and the nums2 is 3, 0 and -6, and you can see the output is 18. So how the output is 18? Because we have chosen two elements like 2, 3 not 2, 3 sorry 2, -2 from the nums1 and 3, -6 from the nums2. So how can we get the dot product? Dot product is simply element by element multiplication. So 2 cross 3 plus -2 multiplied by -6. So this will be nothing but 6 plus, because these both are minus, so minus minus becomes plus, 12, so it gives you 18. So that's why your output is 18. So we choose subsequence 2, -2 from nums1 and 3, -6 from nums2 to get the maximum dot product as 18. Now how will we be able to solve this question? Obviously I just explained you, by the help of longest common subsequence analogy we can do that. But how we can say that okay, we will be using this analogy? Because if you look at this particular problem, you have a lot of combinations and you can't decide like if I will choose this number we will get the maximum, or if I will skip this particular number I will avoid the minimum things and all of that. So like there is no particular idea like if we choose this set of elements, then only we will be getting the maximum. Even if you think by skipping negatives, that also won't work, because two elements that are negative are multiplied together, that will give positive. So we can't skip either the negative elements as well. So we don't have any greedy way or a logical way by which we can say that okay, by this method we will always select or not select a particular element. So we don't have any like particular way of doing it. So we need to try out basically all combinations. So try all combinations. And to try out all combinations, and if you look at the constraints of the questions, constraints are also very low. So we can actually try out all the possible combinations. So we can try out all the combinations with the help of recursion, and then in the end we will just memorize it. So this is how we'll be solving this particular problem with the DP. Now let me show you the drawing explanation how we will be approaching the DP, what all will be the transitions and all of that. So this is the first example that I have drawn so that it is easier to understand and visualize how the things are going. So this is the same array as of the example 1. This is nums1 array and this is the nums2 array. So 2, 1, -2, 5 nums1 and 3, 0, -6 from nums2. So initially we will be at the 0th index of both of the arrays, and we will have three choices. Either we can take both of the elements, either we can skip I element, that is element from nums1, or we can skip jth element from nums2. Now you can say that why we cannot skip both of the elements? Simply because the question has said that you can't have non-empty subsequences. So if you can't have non-empty subsequences, you won't skip both of the elements. You try to pick either one of them. So how will be the conditions be followed? So if you take both of the elements, this will simply take ith element from nums1 and jth element from nums2 and solve further. Now this will make sure that we get a pair in future as well. So this is nothing but we already have a pair and try to find one pair as well. So this is just that. in this we are trying to expand our subsequence window. So this will make sure that if we are taking one element from, let's say, nums1, and let's say one element from nums2, so this window is open for another elements to put inside. We are not restricted that okay, we have taken one element from nums1 and we have taken one element from nums2. No, this means that we can expect more, we will expect more elements here as well. So that's why we will solve this with the help of recursion to get further pairs in the future. So how will the condition get followed? So if we are at I at the 0th index here, so we will just move one step forward. So now we are at index 1, which points to 1 in the nums1 and 0 in the nums2. What will happen if we skip the ith element? Simply just go I plus 1 and j will remain as it is. So we go I plus 1 and j will remain as it is. What if we skip the jth element? Simply I will remain same position, j will go one step forward. So if j will go one step forward, we will be coming at this element which is at index 1, which is nothing but 0. Now I'll not explain each and every like scenario, like all the three scenarios for all of these things. I have just taken one scenario, like one of the cases in which I am explaining this part. So let us see further how this will happen. So if we just break down this part into more scenarios, so again we will have three scenarios, because now we move on to the like next part, the next recursive step. So again we will have three choices, either take both, skip I, or skip j. So if we take both, we take nums1 of I multiplied by nums2 of j, and we will solve further. So if we take nums1 of I, so we will have this particular I1, and for j we will have this 3. So and then we will again move forward. So we will move our I pointer to I plus 1. So here I was initially here, so it will move one step forward, so it will be here to minus 2, and initially j was here at 3, so it will be plus 1, so it will come to 0. It will come to 0, not here. Yes. Now we will have the second scenario. So second scenario is skip I. If you are skipping I, simply do I plus 1. So our I plus 1 would be pointing to element minus 2, and j will remain as it is. So j will be here, not here. So I don't know why I have written like this, but yeah, fair enough. The third scenario will be simply skip j. If we are skipping j, I will remain as it is at this position, and j will move one step forward. So j will be pointing to 0. So it should be pointing to 0, not minus 6. Yes. So that is how things will be followed. So again we will have more scenarios for this and this, but I hope you get the intuition how we are getting this things actually done, actually how this recursion thing is actually working. So this is how it will go further and further and give us the maximum possible answer. So we will take whatever gives the maximum from skip I, take both, or skip j. So this is how we'll be doing with this DP approach. So let us see how will we actually doing, what all conditions will be there. So this is the base case. So base case is nothing but if we go out of bounds in any of the array, let's say if I is out of bounds in nums1 array and j is out of bound in nums2 array. So if any of the array gets the index or the pointer I or j gets out of the bounds, so we simply return minus 29. Now why not int min? Because we are adding everything to our answer, right? Whatever pairs we are getting in the dot product, let's say we have element 2 multiplied by minus 2 plus 3 multiplied by minus 6. So in the end we are returning, when we are returning, we are adding something to it, right? That's how dot product is being calculated. So if you return int min and you add something to it, because since it is the least value inside the integer range, so whatever you add, let's say it is a negative value, so it can't go further negative, so it will give you runtime error for the integer out for the like value which is getting overflow in the integer range. So if you return int min, it will give you integer overflow. So that's why not return the least minimum value, just return a very negative value. So for that's why we are returning minus 29. Now we will be having three scenarios. What? Take both, skip I, and skip j. So in take both, we will simply take ith element from nums1 and jth element from nums2, and we will do the recursion to get some other pairs as well. In skip I, simply skip the ith element and keep j as it is. In skip j, keep ith element as it is and skip the jth element. In the end, there is one more thing. Now we have explicitly said that we are not skipping both the elements, because that will for sure have one scenario that we will return a non-empty subsequence. We will end up getting non-empty subsequence. But what if you are skipping I, in the next step you are skipping j, in the next step again you are skipping I, in the next step you are again skipping j? So in that case also there can be one scenario that you didn't choose anything, you return an empty subsequence, right? So to avoid that case, we make sure that we at least pick one pair. So at each and every step we are also taking the ith value from nums1 and jth value from nums2 to compare, so that we don't return empty subsequence in the end. Because obviously if you skip I in the first step, j is as it is. In the next step, let's say you skip j, so current scenario would be what? Here I would be at I plus 1, j would be at j plus 1. In the next step, let's say I'm writing it here, you skip I again, so I will be at plus 2, j will be at plus 1. In the next step you again skip j, so I will be at plus 2, j will be at plus 2. So it can be possible that you end up taking empty subsequence. So in that case you will be returning minus 29, but you don't want that. You don't want to return an empty subsequence. So for that, at each and every scenario, at each and every step, we are at least trying to pick one element from nums I and nums j. So at this case we always try to get at least one pair. So that's why we are writing this case explicitly, so that we don't end up getting an empty subsequence, which we actually don't want. So in the end, what will be the condition? Whatever is the maximum from take both, skip I, skip j. Now again, skip I and skip j can return empty subsequence. So that's why we make sure that we take at least one pair. So that's why we compare it with value also, because value will make sure that we will always take at least one pair. So that's why we are comparing it with value also. So this is how this entire problem is solved. So I hope you understand this problem. I have tried my best to explain with the help of drawing explanation and all of this. So I hope you understand this problem pretty much in easy way. So let us see the code now, so that you can have better understanding for this particular problem. So this is the code. So first I have declared two integer variables n and m, which is nothing but the size of nums1 and nums2 array. Then I have created a 2D DP. Why 2D DP? Because in this particular question, the two things are changing when we are doing recursion: I pointer and j pointer. Either we are moving both of the pointers ahead, or we are moving one pointer at a time. So two things are changing, that's why we have created 2D DP. We are initializing it with minus 29. Then we are calling this solve function to get the maximum dot product that we can get. So in this solve function, first is the base case. If we go out of bounds in any of the array, nums1 or nums2, just return minus 29. Why not int min? I have already told you in the drawing explanation part. So we are returning int min. We are not returning int min, we are returning minus 29. Then we have the simple memoization check. If you have already solved a sub problem before, just return the answer for that sub problem. Then we have three scenarios. Either we can take both of the things, both of the elements, we can skip I or we can skip j. So to take both of the elements, we are simply taking nums1 of I and nums2 of j, and we are solving it further. Then in the skip I, we are just moving our I pointer ahead and keeping j as it is. In the skip j, we are keeping I pointer as it is, and we are moving j pointer one step ahead. In the end, also one more thing, that we are keeping val also, so that it will make sure that we don't end up taking empty subsequence. This will make sure that we always choose at least one pair. So at least one pair. So in the end, we are just comparing whatever gives you the maximum. Take both val, skip I or skip j, just store it into our DP and just solve further for the recursion part. So this is how we'll be solving this particular problem. And if you want to solve more DP problems, I have already created videos on a lot of DP problems. So I will link few of the important DP questions in the description. So you can just watch that out or solve that particular problems as well. So yeah, that's it for this particular video. And also just a little task: if you can tell the time complexity of this particular problem, you can just comment down what is the time complexity and space complexity as well for this particular problem. So comment that what is the time and space complexity for this particular code. And yeah, that is it for this particular video. So thank you for watching.